Oh my god, the computer's so slow. All right. Does anyone have any requests on topics I can cover? Otherwise, I'll just cover the homework. All right. Homework is. Let me figure out what the heck the homework was. Anyone tell me what the homework was for extra points? Oh, Project Euler number 5.
Can we cash into extra points for something?
Cash. Did I give you extra points? TA, does she have extra points?
I don't care.
I think I might have a new spot for opening for TA. All right.
TA get extra points for being TA.
If it's not you, yes. Okay. So let's do problem number 5, I guess. So it says here that's the smallest number that can be divided from every number from 1 to 10 without a remainder. What's the smallest positive number that can be evenly divisible by all the numbers from 1 to 20? Cool. So usually how I approach these problems, actually a lot of people do this as well, is they write a brute force solution. And a brute force solution, for people who don't know, is kind of like an exhaustive search. It's like an inefficient solution, but it's only done for the purposes of getting a correct answer. It's obviously not a great solution because it can't scale, but it's good so that you can check your answers, or else you won't know if you're right or wrong. So let me copy this prompt over to our Python. Oh, that's so slow. Try to make it bigger. Oh, too big. All right. So, does anyone have? Everyone's eating. I don't know if they can think at the same time. Does anyone have any guesses on how to solve this using a brute force solution? So I'll call this divisible by. And then it will take in it'll take in a range. So it'll take in I guess a target. So we're gonna have a solution here. That's what we want in the end. Let me think. So basically what this problem is like, what's the smallest number which can be divisible by 1 and 2 and 3 and 4? So easy way of finding immediate solution, not of the smallest number, but of a number, is just you could just multiply everything, right? So if you just multiply all these numbers together, obviously whatever the solution is, that's going to be a number which is divisible by all of these numbers, right? But it's not going to be the smallest solution. But we might know for sure that that is a solution you can start with. So what we can do is, and this is basically factorial. Actually, I can teach you guys about libraries at the same time. So what we want to do here is kind of like factorial. At least we want to start off with a factorial. So there's a library in Python called math. Some of you may be familiar with it. To import it, you just type in import math. Pretty straightforward. Use it, you can type in math, period, and then you can check out all these like cool things. So some of them might be familiar, you know, arc, cosine, arc sine, ceiling. Ceiling's useful. Ceiling's actually very useful for like day-to-day stuff, more or less. If you have to like round numbers up, round numbers down. Degrees, not really quite sure what that does. Floor, opposite of ceiling. Factorial, there it is. Nice. So let's check how it works real quick. Factorial of 4. And then we can just like return this. Or actually, let's do the factorial of our target. And here we will call our method. So let's do factorial of 5. Give that a run. 120. All right, that's probably correct. Okay, cool. So so the question was, what's the smallest positive number that is evenly divisible by all the numbers from 1 to 20? So let's put in 20. And we're going to probably get a huge number. Yeah, that's a huge number right there. I should probably close this stuff. That's our secret sauce. No! I should have been looking at my screen instead of the... All right, sorry. All right, so that's a huge number, right? That's a very, very big number. There has to be, I'd hope that there's a number smaller than this number that is divisible by everything from 1 to 20. But we can start from this. So we will do the factorial of 20, and that is our solution. That is a solution, but that's not the small solution. So now what we are going to do is we're going to think of a way of finding a solution smaller. So one way we can do this is that we obviously, so this huge number, right? If we take this huge number, we can start going down. We can make a loop which goes from this number to 0, or I guess for 20, until 20. But anyways, we can go from this number to 0 and until we find a good solution, right? But that's kind of inefficient. Actually, let me make this number smaller. Let's make like let's make 5 or whatever. Just for well, anyways, it was 120. So the factorial of 5 is 120. So if we want to find a number which is smaller than 120, which is divisible by all the numbers from 1 to 5, what checking 119? Pointless, right? Because you can kind of, as a human, you can look at 119 and you could be like, duh, that's not divisible by 5, right? So to optimize this, we could skip every 5 steps, right? We can just immediately check 115, right? And then we don't need to check 115 if 115 is divisible by 5. We can check if it's divisible by 4, and so on. So that's a small little, so that's kind of like the essence of programming, is you find a small optimization and you can apply it across the board and you'll save yourself computing time and stuff like that. So we started with a huge solution. I wonder if there is a, actually let's try to solve their sample problem. So the sample problem is you start with 220, the 220 is the solution, and then you do factorial of 10. Do factorial of 10, you get the solution. So we're gonna make a loop. It's gonna be just I, range, maybe for you, for everybody in that lesson when we went over range. So we're gonna start from our solution, which is, I actually don't know what it is. We'll find out, I guess. And then we'll go to, I guess, 0. It doesn't, so in this case, it doesn't really matter how big our loop is, because we hope that our loop will exit or finish before it gets to 0. And we hope for that. Actually, maybe you should put a limit on it, because I'll cover that later. Okay, so we're going from our solution, which is a big number, probably. Let me print it out just to see how big it is. Comment this out. Let me print this real quick. Whoa, yeah, that's big. Yeah, that's clearly not the smallest number. So we're going from this number, this huge number, which is 3 million. Wow. We're going from 3 million to 0. And if you guys remember how to skip by a certain number in a loop, it's the third parameter in range, so we can skip every target, 10. So it's going to skip every 10. And we could actually test this, I suppose. Let's put in 100, and we could put a print statement here. We could print our I. Now if we run this, that's curious. Oh, we have to put, oh, all right, quiz time. Does anyone know what's wrong with this? Why isn't this working? It seems pretty straightforward. Let me comment out the stuff we aren't using. It seems pretty straightforward. We're making a for loop. we're going from 100 to 0, and we're skipping every target, and our target is 10. Yes?
It should be like negative target.
Yep. Correct. Bonus points. So let's put a negative sign here. Hopefully that worked. Ah, yeah, it worked. Cool. So it's going from 10, or from 100, 90, 80, 70, 60, 50, 40, 30, 10, and none, which is, it just stops, I guess. Great. So our code works. So this is actually a good little exercise what I did here. Instead of moving forward with my example, I decided to test my for loop, right? Because I didn't catch this. I didn't catch that I needed to make target negative until I tested it, right? If I kept going with trying to solve the problem, I would have left this bug until the very end. And then once I had more complicated code, and once it didn't work, I would have had to try to figure out what broke. But here it's very clear what broke. Oh, it has to be in this for loop. So it's kind of just like a lesson to everybody, just to test. If you're not close to 90% sure about some piece of code you write, just test it. And actually, here's another little tip for you guys, and I do this occasionally too, is if you want to test a certain piece of Pythonic magic, you can open a command line. And I think you could do this even in Windows, but if you have a Mac or a Linux shell, you can just type in Python or Python 3, and then you could test stuff here. So for example, occasionally I want to test certain sets. So I'll put I'll make a list A, I'll put some stuff in it. I'll make a list B, I'll put some other stuff in it, right? And then if I want to get the difference between A and B, I can do something like this. Oh, it doesn't work. I guess that's not how that works. So I guess I have to cast A to the set, and then I have to, and then can I do this? No, I guess that doesn't work either. So I guess I'll just do dot difference. Does that work? Oh, that's cool, that works. So now I found the difference between A and B, and the difference between A and B is 1, right? That makes sense. So here, I don't have to Google. Well, Googling is good, but I don't have to Google to figure all this stuff out. I can just tinker and mess around and explore. So once I figured it out, I'm like, okay, is this what I want? No, I want the 4. So let me flip this around. Let me do B difference A. Oh, that doesn't work. Okay, well, what's wrong with it? Maybe I probably forgot to make it be a set. There you go. So I can copy paste this piece of code into my code, and so you can use your Python command line for testing purposes for small things. But if it's complicated, I wouldn't prefer it because it doesn't have a debugger like PyCharm does. All right, cool. So now we're going from this big number. We're going from this big number solution to 0, and we're checking if it's divisible each time. So let me think. What would be our next step? Any ideas? Well, I guess our next step is to see if it's divisible by our next number, right? And what's our next number is our solution minus 1, right? Which is 9 in this case. So now we will check if it's divisible by 9. So what we can do, we can do something simple like if I guess I'll just call it I. And I think we covered this last time, is the modulus function. So what that does is it gives you the remainder, 9, or it's not 9, it's the solution minus 1 is equal to 0. So that means it's easily divisible. So sometimes if you forgot a little bit of review, for example, 4 is divisible by 2. Where's my modulus? It's divisible by 2, so this will actually equal 0. And so if you use the double equals command, so a double equals command is a comparison. Actually, let's check this in our Python code. Why am I doing this here? 4 modulus 2 is 0. Cool. So now if we make that equal to 0, it's true. That's nice. And then if we test other stuff like 5, that's not divisible by 2, so it's false. Cool, that works. All right, so if it is true, what are we going to do? We're going to check our next thing, right? We're going to check I modulus solution minus 2. So now, what did we just discover? We just discovered a little bit of repetition, right? So now we can try to think of a programmatic way of making this more efficient. So what we see here is we see here that our 1 and our 2, what we subtract by is incrementing. So we can make that a loop. So our loop will be our k in range. So we are going to go from 1. I guess we're going to go from 10 till we get 0. So I guess it would be from 1 to solution minus 2. Because 10 minus 2 is 2. Okay, yeah, I mean, there's no point in dividing it by 1. Everything's divisible by 1. So this is going to loop. So we can make a little comment here. This is going to go from 1 to all the way down to all the way up to 9. Well, all the way up to 8. Sorry, because 10 minus 8 is going to be 2, and it's good to check if the number's divisible by 2. All right, cool. So now we can get rid of this, and we could put k here, and then we should probably test that. So how about we put like some dummy code here? Let's put a breakpoint here. There's a problem with our if statement. That's interesting. Indent expected. Oh. Okay. Yeah, that makes sense. Cool. So now we'll debug. And what I'm trying to discover here is what our I is going to be. So we started from, that's interesting. Oh, it didn't subtract anything by it. It's
Solution minus 2 not work.
no, it's fine. What it's doing is it's taking solution minus k. Because our I is the same. So what? So this is, see, I didn't detect this when I was writing the code, but I can see this clearly in our debugger now. What the problem is? The problem is that our I is the same thing as our solution. So of course it's divisible by 10 and it's divisible by 9 and all this stuff because I did the factorial on it, right? So to solve this, I guess we could just take our solution, what we start with, and then subtract it by our target. That makes sense. We start with this huge number, but we don't want to like check if this number is divisible by everything, because it is, because we did the factorial on it, right? It's our solution. So we'll subtract it by 10, and which is the second biggest possible solution. That made sense. So let's debug again and see what we get. So now what we're going to get is we're going to get something interesting, I believe. Look at this. So subtracted it by 10. All right, so now what we're doing, so what is our I? Our I is, well, it's this big number. We try to divide it, we try to modulus by, oh, not by the solution. See, that's incorrect. Right here. Also, I forgot to do the comparison. Man, I'm really screwing up. So it's good that I'm using the debugger. So, so yeah, this line of code is almost entirely pointless. Let me try to evaluate this to see what we get. We get a number in our if statement. We put numbers in if statements, it's true. That's kind of weird. I actually didn't know that. We want, right? We want a true or a false, right? So what we're going to do is, let's actually wrap this in quotes to make sure we have an accurate solution. So we're going to wrap this in quotes, and then we are going to make it equal to 0, because that's how you check if something's divisible. Debug again. And let's see what's wrong now. So now we have solution minus k, which is, oh, I see what's going on. It's not our solution, it should just be our I. Duh. All right, let's debug again. Because yeah, it's no point. I'll just debug it again. Oh, it's running for quite a while. It's interesting. I guess it's not finding a match, I suppose. Oh, it stopped. Oof. That's good. That's actually good that it ran for a long time because it's going through 3 million entries. It's good that I was patient. So, all right, so let's look at our K because, well, no, not our K. Let's look at our I. No, our I's, that's not good. All right, our I is exactly where it was. No, I guess our K is the right thing. So here we kind of coded an inefficient solution. So let me review briefly what we were doing. Is we took our really big number, we subtracted it by 10, and then we take a K and we're gonna subtract that by our it's because what we're doing is we're dividing. We already subtract. So we have this number. We divide it by 9. We divide it by 8. We divide it by all these numbers, and so this is 10, and this is going to be start from 1. So the first one's going to be a 9, and the second one's going to be an 8. Or I guess the first one's going to be a 1. Oh yeah, 10 minus 1 is 9. This is going to result in a 9, and we can actually check this. We can select this into code, evaluate the expression, and it's actually not going to work yet because I didn't wrap it and I didn't recompile it. Let's evaluate this, and now we have a 5, which is weird. Why do we have a 5? Oh, it's because I put so it's because our K is a 5. All right, cool. So what we discovered here is that this is 5, and 5 is divisible, goes into our I, which is correct, right? Like if you look at our I right here, it is divisible by 5. Well, it's because it's divisible by 10, duh. But what we should have done is as soon as it's not divisible by 9, we should have rejected it and moved on to our next I, if that makes sense. So let me rename our variables. I feel our variables are very confusing. In fact, I'm confusing myself. So let's rename our I. Oh, great time to teach you guys about refactoring. So as you can see in this code, there's a bunch of K's, there's a bunch of I's. There's not a bunch, there's maybe like 2 or 3, but still. We don't want to go through here and change them all. So we can just select it, right-click this, hit refactor, rename, and it's actually going to change them everywhere, which is really convenient. So what's a better name for our I? A better name for our I is possible solution. Actually, make it short. I could do possible sol. Posse sol. Say that too often, but anyways. All right, so we have Posse Sol, and then we have our K. Now K is a terrible name also.
Posse Sol is better?
Possible solution. Yeah. So our K is what we're dividing by. So it's going to be, I guess, our divisor. I'm going to call it divvy. All right, cool. So we could kind of see a little more clearly what we are. A solution, I mean, why call it a solution? It's not a solution, is it? It's just what we start with. So we're going to rename our solution to, anyone have any ideas? I guess starting point. So I guess start. Yeah, cool. So let's reread through the code real briefly. We have our starting point, which is this big number. We subtract it by the target, which is 10. So now we have a smaller number, and we're going to go from that number to 0, subtracting every 10. And every single time we have a possible solution, right? And we have to check if that possible solution is good or not. How do we check? We divide it by stuff. What do we divide it by? We divide it from 1 to 9 or 8, whatever. So we take our possible solution, we try to divide it by 9. And if it's equal to 0, that's good. You can continue. But if it's not equal to 0, that's bad. So what you should do, you should break. Because what's the point? Because as soon as something's not divisible by 9, why go check if it's divisible by 8? You already know that this is not a good solution. So you should break. Now the trick here is I believe that the break, actually let's debug to this point and see what happens. Cool. So what did it find? It found that our divisor, which is in this case 1. I am going to flip this around and make this a lot more clear. Cool. Now it's a bit more readable. So now our divisor is, give it a second, our start, oh, not our start, our target. Oh, it's still also not good. So our divisor is target minus 2, which is 8. Well, it should be 1 actually, because we start from 9, and then it's going to go to 2. Oh, it's not going in there. It's interesting. All right, let's figure out why. So let's put our breakpoint here. Oh, it's because I'm not, okay. Anyone figure out what's wrong off the top of their heads? What's always the solution in my class? I should learn this by now. What's always the solution if you don't know it? Yes. So, so what I did here is that it's not going to this breakpoint. That's not good. It's not going to this breakpoint. That's not good. Let's check this breakpoint. Boom! It stopped. All right. So now let's check what our target minus 1 is. Target minus 1 is 9, and we go to 2. But what are we missing? We're missing our decrement. That's why it wasn't going anywhere, because it hit this for loop and it immediately said false. So obviously you could have just like stared at your code and figured it out eventually, or you guys could have just figured it out in like 10 seconds. All right, let's try again. All right, cool. So now we have something. So now our divisor is 9, and our possible solution is this big number, right? So what we did is we tried to divide 9 into this big number, and it said false. Great. Now we're gonna break. So let's go to the next line. So we broke to this big for loop, which is good. Now we're gonna go to the next possible solution, which is 7. It's a big number. And then we're gonna try it again. Divided by 9. It's not good. Divided by 9. It's not good. Divided by 9. Not good. We're gonna keep going for a very long time. All right, cool. So now we have a piece working. It's going to send this number plummeting down, and you can see it's already. You can see the number. Oh, that's good. What did I do?
It might be the Chromecast.
Oh no. See, this is why I don't like technology. Well, the people at home could see what I'm doing. Wonder how many viewers I have. All right, let me try to fix this Chromecast. Hangouts is sharing your screen. Oh yeah, I did lose the Chromecast.
Yeah.
Ah, you just leave it on the same page.
Wait, do you have a HDMI port?
Yeah, I do. Should have just been using that the whole time. But I think I got it working.
Chromecast?
Yeah, there you go.
Yeah, that's working.
Yeah. All right, just give me the cable.
What does it say? It's 4.
Probably says HDMI on it. Wow. Frick. Yeah, this is why I don't like technology. What in the world did it just do to my computer? What in the world? I didn't even know I can get this resolution. Was this a 4K monitor or something?
Go to displays,
All right,
display settings, and then make sure it's not mirroring.
Ugh, it's not displays. It's screens. No.
Wait, it's not that? Really?
Oh, you're right here. Display preferences. It's not mirroring. I want it to mirror.
Display preferences.
Yeah, I clicked it.
You can change the what's it called?
Scaled?
Yeah, the scaling.
Oof, that's big. 1080p. All right, hopefully I'll fix some stuff. All right, cool. It's a little bit better. Sorry for the technical difficulties. You can blame my TA. All right, cool. So I can even make this full. No, I guess I can't make it full screen. Oh, I can't make it full screen. Increase my resolution a bit. All right, cool. Awesome. It actually looks even sharper than before because screw Chromecast. All right, cool. So yeah, you can see this number plummeting. You see it's going. This number on line 10, it's going down. It's checking every 10 steps whether it's divisible by 9. Actually, we just saw something interesting. We just found a number which is divisible by 9, but it wasn't divisible by 8. Oh, there you go. That was it. So now it was divisible by 9. And we can actually check this, I guess. But what's the point? So it was divisible by 9, and now it's going to try to divide this number by 8. So we kind of have like some good functionality here. It's working kind of as intended. Obviously, we can add optimizations, but that optimizations should usually come later once you understand. So yeah, this number was not divisible by this number on line 10. This was not divisible by 8. That's why it went inside here, and it broke again. So this could actually potentially find you the solution. But what we don't have here is something called a base case. So a base case, so it kind of works, right? But we don't. What we don't have here is when we actually find this number, which is divisible by every single thing. Ooh, wow! It's divisible by 9 and 8. Is it divisible by 7? No. So we're gonna continue searching. So let me break out of that, so we can kind of see that it's clearly working, which is really great news. But we don't have any way of saving our solution, right? So let me make a variable up here called solution. Let's put it to 0 for now. We're going to replace that with a value. And at the end, obviously, we're going to return our solution for points or whatever. Okay, cool. So if it breaks, it's going to hit this, right? But if it doesn't break, it's not going to go into this if statement. It is going to, what we're going to do is we're going to check if our divisor is equal to 2. That is our solution. It's fun to say. So what did I do here? So our divisor is going from, let me rewrite this a little. It's going from 8, or it's going from 9 to 2. Right? We're going to check if it's divisible by 9, 8, 7, 6, 5, 4, 3, 2, 1. When it hits 2, it's going to check this line of code, right? If it is not divisible by 2, it's going to go inside this code and it's going to break immediately. It's not going to hit this line. It's going to leave this for loop and it's just going to go to the next posse sol, right? But if it is divisible by 2, which is good, it's going to go to this line. And here we're going to ask it, hey, are you divisible by 2, or did we just divide by 2? And it's going to say yes, which can be like, oh wow, that's great news. So now we have a possible solution. So it's great. And then at the end we return a solution, and let's run this. Now we got 0. More debugging to do. That's not fun. All right, so see what happened here. So let's put a debug point right here, and let's see at what point it actually hits this number.
Can I ask a question?
Yep.
So the break over there, we have like 2 levels of for loop, the nested for loop. So the break, it breaks like the nearest for, like,
yep.
or the big, like which for loop it breaks?
Yeah, good question. I was actually gonna cover that. So it breaks. So usually when you put a break, it will break the nearest one. However, sometimes you don't want it to break the nearest one. You want it to break the second one or the third one. I mean, it's usually not great practice to have 3 for loops nested inside of each other, but sometimes it's a necessity. So to do that, we use something called flags. So I'm actually going to have to review some stuff because I actually haven't messed around with these since Java. since I've coded in Java. So what you can do here is you can do like flag colon, and you can do break flag. Yeah, did not like that. Let me Google. Oops. Let me Google how to figure this out. So how to Google this? It would be break flags Python. Alternatively, you can add a break flag, but I'll explain that soon. See how this guy does it for any break flag, blah, blah, blah. Wait, what was this guy's question? Breaking for nested loops without executing subsequential code. Ah, this guy just rewrote the thing. Sucks. This one, wait, where was it? Break out of multiple for loops. That's the one we want. First instinct was to refactor the nested loop into a function and use return to breakout. Yeah, that's usually a good idea. I was going to cover that later. All right, that's fine. People don't really have a solution. If they had a solution, oh, well, there probably is a solution, but it's not good practice to use it. So, oops. Where did it go? Oh, there it is. All right, cool. So, that's a great question. So, what we're going to do is I will show you roughly how it works. So, there's two things you can do. There's one thing you can do is you can put a flag here, and you can set this flag to true. You could add a flag here. Well, you have to set the flag to a default value. So you could add a flag to false. And then here, or at some point where you want to check it, so that might be here, if flag, if that's true, then you will break. And it will obviously break out of the first for loop, which is like, yeah, you just copy the functionality of break, more or less. But now you have another if statement at the end of this for loop, which, because when this break hits, it's going to go not to here, it's going to go to here, because this is it's in the same block. So we're going to have a flag here. It's going to have another break. Then you could keep doing this, and it's obviously going to get ugly. So that's why the person on Stack Overflow recommended to make these into functions with return statements, which I will cover once we have finished solving this problem. So for now, break kind of sort of works. Something else doesn't work. So we'll figure out what that is. So the reason it doesn't work is the divisor is equal to 2. Curious. So another tip for debugging is let's write a special case in order to get closer to what we want. So maybe we can find something which is divisible, a number which is divisible by everything from 9 to 4. So what we're going to do is when divisor is equal to 4, we're just going to put like some gobbledygook here. We'll put our breakpoint here. So now our breakpoint will go into here when divisor happens to hit 4. Hopefully it will hit 4. All right, it did hit 4. That's great. Awesome. So there's this number right here. Wow, that was not too far off. But anyways, there's this number right here on line 10. And this number is pretty great, because this number seems to be divisible by 9, 8, 7, 6, 5, 4, not 4. We haven't tested 4 yet. We're going to test 4 soon, which is good. Let's test if it's divisible by 4. It is divisible by 4. That's great. Next number is 3. It is divisible by 3. That's great. And then it leaves. Oh, I see. So we just found our bug. I expected it to go to 2. It didn't go to 2. That's why this is never saved. So why is that? It's because our for loop right here, it's exclusive instead of inclusive. So it doesn't include the last number here. So it goes from 9, because this is 9, right? But it doesn't go to 2, it goes to 3, because it goes from 1 plus this or whatever. It's kind of a weird quirk, but you get used to it. So what we're going to do is we're going to change this 2 to a 1. Cool. So now our debugger is still running. Let me run this. Whoa. Oh, it's because I have the print statement here. Duh. No. Stop. Well, I don't need this anyways. It served its purpose. Cool. What did it just print for us? It printed 2520, which is, according to the prompt, the smallest number that can be divisible by every number from 1 to 10, which is great. We just kind of sort of solved the problem. Well, let's put a 20 in here and run it. And as you can see, it hasn't finished running in quite a while. It's because we found an inefficient solution to this problem. This is not the ideal solution to this problem. However, it is a solution. And when it finishes running, because it's actually might take quite a while, because for 10 it was 3 million, and for 20 it was an exponential number greater than that. But that's actually why I wanted to recommend Project Euler to everybody, is because it makes people think slightly more efficiently about their solutions. So obviously I found a code which solves a problem, but it's not efficient. It's because it's running for longer than like 20 seconds, which is kind of insane. But when it eventually finishes running, which might not be soon. So let's think about how to make this code better. So we kind of understand what it's doing. It's skipping every 20, I guess, in this case. It's skipping every 20. Actually, let's change this back to 10 so we can debug it easier. So I stopped it because it was running for too long. So we're skipping every 10, which is okay, I suppose. We could also skip every 9. That wouldn't hurt anybody, would it? It doesn't really matter. Whoa, that's interesting. Let me not do that. That was probably a bad idea. All right, let's think about how to make this more efficient. Anyone have any ideas?
Some code like for this solution. Just like to set step as 20 and go 20.
So it's doing something very similar to what we're doing. It's going through every step of 20, and then it's trying to divide it by n, which is going to be our 1 to 20. I don't think that's faster. Did you try running it?
It's like 9 seconds.
Oh, really? Interesting.
We start from 0 and add.
Great idea. Great idea. And as soon as we find a solution, we can just stop. We don't have to go all the way to 0. In fact, that's probably why. Yeah, I realized that, and then I forgot it. All right, cool. So we'll just flip this around. So we can take out our subtract. We can flip this. Start at 0. And try that with 10. Will probably be, oh, that's ugly. All right, why did it do that? So, oh, it's because as soon as we find a solution, we're done. So we can just do our return solution here. Or you just do revert return. That's not good. All right, let's figure out why. So what number do we start with? We start with obviously 0, and we try to divide 0 by 9, I guess. It's obviously not going to work. Wait, what? 0 divided by 7 is true? Okay, well, I agree to disagree. Let's start from 1. It doesn't really matter what, oh, I guess it does matter what we start with because we're adding to the target every single time. Let's start with our target, all right? Our target is is 10. Can't go wrong there because it's every 10 steps. Cool, awesome. So let's try to put in 20, see if it's any faster, and time. It's not much faster. However, oh, there you go. We got a solution. So now what we can do for the purposes of this class, I guess. So we can go to project. Where?
Cheating?
No, we have a solution.
Okay.
We just brute forced it. So we're gonna sign in. I don't think I remember. Log in. The confirmation code.
Yeah, I have to know.
They really?
Missed one.
No, that's not good. Even if I got the digit, I don't think I remember my password. And sign me in. Username was unknown. Okay. Oh, it's a username, not an email address. All right. 5979. Please let me in. Yes. All right, cool. So this is problem number 5, and here you can actually, oh, it just tells you the answer. It's because I solved this already, but that's why. All right, cool. That matches up because our solution was, I pasted it in the search bar. Awesome, we have a solution. Obviously, it's not, it was okay, but maybe we could think of a more efficient solution. But there you go, solved the problem. Cool, in an hour. And like most of the steps I went through were pretty like, weren't magical or anything. I kind of did things very methodical. I didn't pull anything out, but so great. I would guess that's class. So try to do questions. This one was pretty like, you know, it wasn't hard. Right? So it might be, so the trick about most of these are they're hard to understand, right? But they're not actually hard to really do, right? Because they're not asking you for a lot. They're asking for a pretty simple question. You just kind of have to understand exactly what the question is asking you, and then you have to think about how would you go about coding this. And that's kind of how math is devised. Is you start solving something by a small little step here. So I start by skipping every 10, and then I start by dividing by every number and stuff like that. All right, great. Any questions? Any recommendations or for future material? Awesome. I'll choose a Project Euler question, which is appropriate, which shouldn't be much harder than this one. Great.
We don't have to do it next week, but it'd be cool to iterate on the stock.
Oh yeah, sure thing.